Hi guys, my name is Jonathan Wong, student number 1916203. I'll be covering calculations related to this problem.
Hi, my name is Nolufe Shezi, student number 885460. I'll be introducing the problem and stating the assumptions.
Hi, my name is Kigela Slechema, student number 1907668. I'll be doing the experiment.
My name is Avukile Sokasha, with the student number 1906167. I will be doing the interpretations of the results after the experiment and also recording the data during the experiment.
We're here to prove the law of buoyancy that states that the force of buoyancy is equal to the weight of the fluid being displaced. We chose a problem in the mechanics of fluids, 4th edition, I think, H. Shames, problem 2.76, that states that a cube of a certain dimension is being lowered into a container filled with water till the edges, and we are required to calculate the volume of the fluid that is being displaced. And we came up with assumptions that we are at a temperature of 20 degrees Celsius, of which when we checked the textbook by Potter, for density at that temperature it was 998.2 kilograms per meter cubed. And we were advised that there are no appreciable waves during the experiment, and we are advised again that there are no adhesive.
Okay, I'm going to do theoretical calculation. Firstly, let me start with the schematic for our problem. We have our bucket, we have our block, submerged, it is open to the atmosphere. So here we have our weight, then we have our buoyancy force. Then this mass, when we measured it, it was 0.140 kilograms. And from the assumptions, since the temperature was 20 degrees Celsius, the density of water equals to 998.2 kilograms per meter cube. So going through the calculations, we have this, so we can split some of the forces in the y direction equals 0, and buoyancy force minus weight is equals to 0. So buoyancy force equals to the weight. So buoyancy is the density of water gravitating to the volume displaced equals to weight, which is mg. You can cancel gravity both sides, and make volume the subject of the formula, which is equals to the mass of the block all over the density of water. So we can substitute 0.140 kilograms all over 998.2 kilograms per meter cube, which is equals to 1.402 times 10 to the power minus 4 meter cubed, which is equivalent to 140.2.
Hi guys, now we are about to do the experiment. We have our bucket filled with water. We'll be using this because to collect the volume displaced. Now this is the tube that we will be immersing into.
Okay guys, now that we are done with the experiment and we have our volume that we calculated from the problem, Now we will calculate the average volume from the experimental data we have, which is 125 plus 150 plus 160 plus 148 plus 125 milliliters dividing by 5. We get that the average volume is 141.6 milliliters. Now that we have the average volume and we have the volume that we calculate from the problem, we can calculate the error that we got from the experimental data comparing to the volume that we got from the problem that we calculated. That it will be 141.6 milliliters minusing to 140.2 milliliters dividing by the calculated volume times 100 converting to the percentage. We get 0.9986%. Okay guys, now looking to the theoretical volume of 140.2 milliliters and the experimental volume, that is the average volume of 141.6 milliliters, that give us an error of 1%. Now we can say that the buoyancy law has been proven.